Hello everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and embedded systems design having code KEC 061, what we have covered, we have completed unit number 1st, 2nd, 3rd and 4th, and in the previous lectures we have started with the unit number 5. Unit number is all about the Mbed platform. So, in our previous lectures we have covered the Mbed platform, what are its various features, its functionalities, and in the last lecture we have started with the SDK and SDK. SDK means software development platform and kit, and SDK means hardware development kit. So, we have left with the some topics of Mbed platform that we will cover in this lecture. So, in today lecture we will discuss about the Cortex microcontroller software interface standard CMSIS under introduction to Mbed platform. So, these are the table of contents that we will cover in today lecture. I am taking marker. So, these are the table of contents. First one is introduction to CMSIS. So, this is the topic under outline the Cortex microcontroller software interface standard CMSIS tool and its benefit. So, first topic is what is CMSIS, we will cover in this topic. After that, standardization in CMSIS tools. After that, we will discuss the CMSIS in details. After that, what are the various CMSIS components we will discuss in this topic, and the last topic is benefits of CMSIS under the outline the different features of CMSIS. After that, we will cover in the last slide the applications and enabling technologies of CMSIS. Okay. So, let us start with the first topic, that is the outline the Cortex microcontroller software interface standard CMSIS tool and its benefit. So, first of all, what is CMSIS? CMSIS basically, C stands for Cortex, M for microcontroller, S means software, interface, I means interface, S means standard. Here it is right here. So, basically first is Cortex and second one stands for microcontroller. So, we are talking about the microcontroller. Which microcontroller? That is Cortex ARM microcontroller. Here we will talk about the Cortex M0, M0 plus, M3, M5 microcontrollers. In the previous lectures I have discussed the ARM microcontrollers. So, we will comfortable with the M0, M0 plus. Now, we are CMSIS comfortable with the these types of microcontrollers. Software interface standard. Software means this is the software interface that is provided to the users, and standard means it has some standards. For example, if we are writing the program for one microcontroller, it is compatible with the another microcontrollers. So, that is the meaning of the CMSIS. So, let us start with the introduction of CMSIS. CMSIS is a vendor independent hardware abstraction layer for the Cortex M processor series. What does it means? It means that it is a vendor independent. For example, if we are using Windows 7 and Windows 10 in our laptops, okay, if it is fabricated by Intel or HP etc., but this type of Windows 7, Windows 10 will not be compatible with the Apple laptops, because Apple is comfortable with the Macintosh operating system. So, this CMSIS is a vendor independent. Vendor independent means that whatever the vendors are like HP, Apple, it will run in all the system. So, it is vendor independent. Hardware abstraction layer means that it is running successfully with hiding the details, whatever run in the background, it is hiding the details and it is provide the platform to the user. That is the meaning of the abstraction layer. Okay. So, it is a Cortex M processor series. I have discussed that Cortex M processor series means that it is a Cortex microcontroller. So, what type of microcontrollers we are using? M0, M0 plus, M3, M5, M7 etc. Okay. So, it is compatible with these types of Cortex microcontrollers. So, CMSIS provides a standardized software interface. What is the meaning of standardized standards? So, there are certain standards. For example, if we are using CMSIS software for particular microcontroller M0, okay, and if it is comfortable with all the members of the particular series of a microcontroller. It does not mean that it is compatible with the 8051 also. If it is compatible with the 8051, it means that it is not compatible with the 8085 microprocessors. So, for a particular microcontroller family, it is compatible with all the members of the microcontroller. So, it is provides a standardized, means that it has some standards, it has some protocols, so that if we are dealing with particular one microcontroller, its software will run on the another microcontrollers as well. Okay. So, such as library functions which help you control the processor more easily. For example, configuring the nested vector interrupt controller NVIC. What does it means? Basically, CMSIS is basically a software standard interface. It provides software solution to the user. User can open it is a open source software. It is easily available in the if you are searching in the Google, you can use CMSIS software in free of cost under some license agreements, etc. Okay. So, if so it has some library functions. It is easily available to the user. User can easily use these types of libraries, and it has some, because in CMSIS there are a lot of microcontrollers. So, lot of interrupts are there. So, which interrupt has to handle by the microcontroller, that is decided by the NVIC, that is nested vectored interrupt controller. So, basically nested means that nested vector means that it has certain locations. So, NVIC is responsible to which interrupt is handled by the CMSIS. It is all carried out by the NVIC. Because if we are if in a processor there are lot of interrupts, which interrupt has to handle, it will be looked upon by the NVIC. So, main reason is to improve software portability across different Cortex M processors and Cortex M based microcontrollers. So, it provides improved software portability, means that it is a portable, it provides portable solutions. All the libraries are openly available in the Google. You can search, and under there are data sheets also. So, user can easily use all these library. So, all these are compatible with all the members of the microcontroller, that is whether it is M0, M0 plus, M3, M5, M7, etc. Okay. So, our next slide is outline the Cortex microcontroller, under which we will see some we will see the introduction of CMSIS through some diagrams. So, we will start from here, that is ARM Cortex M0 plus processor. So, we have seen that CM stands for Cortex microcontroller. So, which Cortex microcontroller? It is compatible with all the M0 plus. Here we can write M0 instead of M0 plus, M3 we can write here M4, M5, M7. Okay. It is compatible with all the microcontrollers. M means microcontrollers, so ARM microcontrollers. Okay. So, whatever we are doing here, this is connected with the configure Cortex M0 plus by directly accessing registers in its internal memory space. For example, unsigned INT star MVIC interrupt enable 0 cross 01. So, basically what we are doing, basically ARM Cortex this type of CMSIS software is compatible with all the microcontrollers. So, for all microcontrollers it has some libraries are there. Okay. So, we can directly accessing the registers, because in microcontrollers there are some registers, whether it is general purpose registers or whether it is special function registers, because data is stored in the registers. Okay. So, which register has to access by the microprocessor microcontroller, it is look upon by this. So, it has some type of keywords for that, NVIC underscore interrupt underscore enable. It means that which type of interrupt has to be handled by the microcontrollers, it has to be done by the these types of keywords. Okay. So, this is basically used to enable the interrupt. Enable means we are enabling the interrupt for particular interrupt. There are a lot of interrupt. So, which interrupt we have to handle? For example, this is 0 cross 0 1. If we can write here 0 0 0 1, under this location there is some interrupt. If interrupt, so if for example, if we have interrupt A comma B comma C, so this vector location may be belong to some particular interrupt, maybe interrupt B. If we have a interrupt C that has some particular location 0 0 0 2, for example. Okay. So, which interrupt we have to use? It is enabled by the NVIC. After enabling it, what we are doing? We are using the libraries, open source libraries available in the CMSIS platform. So, how it will be done? We are configuring Cortex M processor by using CMSIS libraries. For that, we are enabling the IRQ timer, basically interrupt request. So, basically interrupt request means that microprocessor send interrupt request to the peripherals. Okay. So, after all the libraries are open available, what we will do? We will go towards the ARM CMSIS core. What is ARM CMSIS core? We will discuss in later slides. Basically, it provides, basically it has some API interface that we will discuss in our next slides. So, all these are compatible with the Cortex M microcontrollers, whether it is M0, M0 plus, M3, M4. So, it is compatible with all the microcontrollers under M families, M members under Cortex M microcontroller. So, these are the basically a picturization of CMSIS introduction. What is CMSIS? So, after our next topic is what is standardized in CMSIS. So, what is the meaning of the standardization? Standardization means we are using some standards in CMSIS. Standard means that we in first slide I have discussed that if we are using CMSIS microcontroller platform that is compatible with the Cortex M0 family. So, if we are writing a program for M0 plus, it is compatible with the M0 also, M5 also, M3 also, M7 also. Okay. It is compatible with the all the members of the microcontroller under M family. Okay. So, it provides some standardized solutions. Standardized means that it is common, it has common libraries, it has reuse can be done, and it has open source functions for all the microcontroller families. So, standardized functions to access NVIC. NVIC we have discussed that nested vector interrupt controller, which interrupt has to be handled by the processor. It will be decided by the NVIC. It has a system control block. System control block is responsible to carry out the functions. It is used to control the execution of the functions, and it has system tick timer. Tick timer means that there are some timers and counters in our system. It has to be taken care of by the system tick timer. For examples, first one is the enables an interrupt or exception. So, if we are going to enable an interrupt or exception handling, what we will do? We will use these types of functions, these type of keywords. That is I have discussed in a previous slide that also. So, we have NVIC enable. What we are enabling here? We are enabling the particular interrupt. Okay. And how it can be done? It can be done by the IRQ, means interrupt request. So, for that we are typing here IRQN underscore type IRQN. So, where we are typing? We are typing in the CMSIS platform, like MATLAB, like other script are there, like Python language. So, we are writing the our programs in CMSIS platform. Okay. So, also it can set pending status of interrupt. So, if for example, if in our processor, I am erasing the things here. So, set pending status of interrupt. For example, if this is a processor, it has various interrupt 1, interrupt 2, interrupt 3 up to interrupt n. Lot of interrupt are has been received by the processor. So, at a time processor may handle particular interrupt according to its priority. So at any time it may happen that some interrupt cannot be handled, it shows pending interrupt. So pending interrupt can be executed by these types of instructions. So void NVIC set pending interrupt request. So set pending interrupt request means that whatever the interrupts are pending to service by the processor, it can be executed by this type of instructions. So standardized access of special registers, for example, so in our system processor there are some registers are here. So the registers are accessed by using these types of instructions. First one is the read primary mask register unit 32 UINT 32. What is the meaning of 32? 32 means 32 bit registers. So it can be executed by this. Okay. After that, set control register void set control UINT 32 means the 32 bit registers, and T means which type of particular value has to be selected, all will be carried out by this type of instructions. So in CMSIS we need to write a program. For program we need some libraries, we need some particular instructions as well, all will be carried out by these types of instructions. So after that we have a standardized functions to access special instructions, REV, NOP. REV means that return value. For example, if this is processor, if we are servicing particular interrupt, for example, we are servicing here interrupt number 2 out of n interrupt. So after executing a servicing particular interrupt, processor will return back to its initial values through these type of instructions. UINT 32 bit processor return from value and UINT 32 from here particular interrupt. No operation, NOP means no operation. No operation will be carried out by the processor if we will use these types of instructions. No operations. That is, the processor will do no operations. Okay. So standardized names for system initialized function, for example, system initialization. How to initialize the system? It will be carried out by this type of. So if we are have some debug functions, some issues, and unable to use some these type of CMSIS libraries, then there is some CMSIS compliant that will carry our queries, our issues. So for that there is CMSIS compliant. This is the logo of that. So all the things will be taken care by the CMSIS compliant. If there is any issue in the libraries, any issue to use them. So our next topic is CMSIS in details. Here we will see the detailed view of the CMSIS, its history, what are its various features. So CMSIS has a modular structure. What is the meaning by the modular structure? That is, modular means that whatever we are writing, we can configure and we can commercialize its activity. So if we are, for example, in CMSIS we are writing program here, this program can be configured, can be used by our any type of project, okay, and each module can be used or updated independently. So in CMSIS, if we have various types of modules, each module is independent to the another module. For example, if we are writing program for particular M0 microcontroller, it is independent to the M0 plus microcontrollers, whatever the functions we are doing here. Okay. So some of the modules are device specific. Device specific means that so some of the modules are device specific means that some modules is it is device specific, that is specific to particular device. For example, if we are using module number 1, it is compatible, maybe it is compatible with the M0, it is not compatible with the M0 plus. So for particular microcontroller, some modules may be specific to that particular microcontrollers we are using. So thus for every ARM Cortex microcontroller family, a collection of CMSIS modules is created, the device family packed DFP. Okay. So in 2008, the Kyle company therefore introduced the new revolutionary technologies Cortex M microcontroller software interface standard CMSIS. So in 2008, Kyle company first introduced this type of CMCS platform to the users. So it has been introduced by the Kyle company. Okay, Kyle company, you have seen that in our 8051 microcontrollers, we are using Kyle software to writing the program, to assemble the program, to burn our microcontroller chips. So all will be carried out by the Cortex Kyle company. Okay, so CMSIS offers a very simple configuration interface between microcontroller code and peripheral units. So it is easy to use. It is provides very simple solutions to the users. So here we will see how the system will be function. So first of all, it has some layers. This is the application code layer. Application code means it is has a user layer. Okay. So this is the CMSIS layer. This is the user layer. I am writing again. This is the CMSIS layer, and it has a peripheral layer. Peripheral devices are there. So three layers are there. First one is the user. This one. This is the these both of them are the CMSIS layers, and the last one is the peripheral layers. I am erasing the things for better view. So how system will work? First one is the application code. Application code means that we are writing the code, we are using the code for the user. So here this is the debugger, and here CMSIS Rtos real time execution. It works on the real time without any delay. It has a machine learning tool. It has a signal processing, digital signal processing are there. In the middleware interface, it has some drivers, because to use the CMSIS we need some drivers. It has a peripheral HAL device specific. It has a CMSIS core. Okay. So in core there are various types of libraries. It has processor core and peripheral access also. So ARM Cortex processor, communication peripherals, specialized peripherals, core side debug logic, all are lying in the we can say that peripheral layer. So all the layers, all the things are in a single chip. That is a system on chip. System on chip means that all the things are integrated on a same chip. So whatever we are doing here, peripherals from data from peripherals go to this, and there is some third party software, that is a debugger. If there is any debugging issue, we are operating from here. So this diagram is also mentioned here in a more compatible form. Here it is application code. We have discussed that application code is for the user here, and DSP libraries, Rtos Api, all under CMSIS layer. And for microcontroller units, for example peripherals, it has a Cortex M0, Cortex M3. So there are three layers. So what we are doing here, if we are writing application code, this is goes to the DSP libraries. So for digital signal processing, the libraries has to be taken from the DSP library. And if we are using the real time operating system, application programming interface, API means application programming interface, all the libraries are held into this API. So core has a processor and peripheral access. So which type of microcontrollers has to be used? It is used by, it has to be accessed by the CMSIS core, and after that whatever we are doing, for example we are writing the programs for Cortex M4, it is has to be go to the SVD. What is the meaning of SVD? SVD means that system, S means system, view, V means view, and D means description. Basically what system has all the things, it has to be configured by SVD, system view description. So system view description has all the functionalities needed to execute the CMSIS software, and all the things will go further into the debugger third party. Third party means that we have any debug issues, it has to be connected through this type of microcontroller. So all these functions are integrated onto a single chip, that is called system on chip. System means on chip means all the system has to be integrated on the same chip, all the things are available. So it has a CMSIS core, it has a CMSIS DSP, Rtos, all integrated on the same chip. So it has various components we have already discussed. CMSIS core. CMSIS cores provides an interface to Cortex M0, Cortex M3, M4 and secure core SC000, SC300. So processor. So it is compatible with the SC000 family of processors as well. It has a CMSIS digital signal processing DSP. DSP library provide all the solutions need to access the signal processing operations. So it has 60 functions in fixed point, Q7, Q15 and Q31. These are the basically libraries, and it has a single precision floating point 32, which is of 32-bit. After that, in the from the another section, that is, this is the DSP, another one is the Rtos API. What is Rtos API? It is a real time operating system application programming interface. It has a standardized programming interface for real time operating system. If we need to work on the real time operating without any delay, we are using this type of library set. So it is compatible with the thread control, mutex, that is discussed in the previous lectures. Resource management, task management, time management are there. All the things are to be carried by real time operating system. So another one is the SVD. We have seen that system view description. So system view description has to be carried out by the XML files. XML files means that it has a .xml file solutions. All the things, all the functions which are executing presently executing has to be included in the XML library. So that contain the programming view of a complete microcontroller system including peripherals. It has a CMSI, a DIP. It has a firmware for debug unit. We have seen that in the diagram. There is a debug third party. So debug third party has to be carried out by this firmware for a debug unit that interface to the code site debug access port. After that, there is a CMSIS zone. It defines methods to describe system resources and to partition these resources into multiple projects. So whatever the various types of resources are available, CMSIS zone will decide whatever the resources has to be used by the particular microcontrollers. Okay. So after that, there is a CMSIS driver. Driver means that we need to install the drivers to access the CMSIS software. So it offers a software API that describes peripheral driver interface for middleware stacks. After that, it has a API that is it has a header files also. Header files means that whatever programming we are doing, it has some header files, and it supported peripheral units for most of the potential cases. So basically, we are dealing with the programs for a particular object. Under this topic, all the things whatever we have discussed, these are picturized here. Here, this is the USB peripheral units, that is a device layer. This is the device pack. Whatever we are doing, these are have all the set of drivers. So for example, if we are using the USB, so there is a USB device driver. If we are using the serial peripheral interface SPI, it has SPI driver. So in CMSIS, there is a driver pack for all the peripherals independently. For example, if we are using input output memory controller, it has a NAND driver, memory driver. So it has a control buses as well. So in the middleware sections, it has all the libraries available to access that particular drivers: USB device, TCP IP networking, graphic file system, USB host. So what are the benefits of CMSIS? Benefits and advantage of CMSIS is that it is easier to port application code. Where it is easier to port application code means that it has easier to use, it is easy to debug, it has easy solutions for the user from one microcontroller to another microcontroller. Okay, it is easy to use and it has less effort to reuse the same code between different Cortex M0 microcontroller. For example, if we are using the core code for M0, it is easy to reuse for M0 plus or M3 or M7, M5, etc. It is better compatibility when integrating third-party software components, since the third-party components such as application, embedded OS, middleware, etc. can share the same standard. So it has a better compatibility. If we are using for a particular microcontroller, it is its code is applicable to all the microcontrollers members under a particular microcontroller category. It has a better code density. Better code density means that in a small code, various types of instructions has to be executed. Code density means that in small memory area, there are more functions, more type of instructions can be executed, and smaller memory footprint since the codes in CMSIS has been optimized. So all the instructions which are using in CMSIS is optimization and tested. After that we are using for a memory. So in our last slide, there are various types of CMSIS SIF partners, and that provides a solution to the our CMSIS platform: Altrum, CodeRat, Kyle, Tools by ARM, AKtU, Atmel, Energy, Micro, Hightex, IAR System, Micremium, Freescale, Nuvoton, NXD, NXP, Resonance, Cigar, ST Microelectronics, Texan Instrument, Toshiba. There are a lot of vendors which are providing solutions to the CMSIS software and its libraries. So there are various types of applications of CMSIS. Applications are common microcontroller software interface standards, Cortex. So it provides solutions for software interface. We can openly use these types of software for writing the programs. So it is compatible with the various types of technologies, IoT, Internet of Things. It is compatible. Artificial intelligence, we can use CMSIS. For robotics, we can use here neural network, deep learning, machine learning. All technologies are compatible with the CMSIS. So thank you everyone for your patience. I hope you have enjoyed my lecture. Thank you everyone.